Hi, welcome to the lecture on kinematics. We're going to start with an overview of what kinematics is. It's a description of motion, and some of the terms that you're going to be seeing are position and displacement. We will distinguish between those. Velocity, both average and instantaneous, and acceleration, average and instantaneous. So speed is a scalar quantity. Scalar means it only has size or magnitude, not direction, just size. And it refers to how fast an object is moving. A fast-moving object has a really high speed, while a slow-moving object has a low speed. It doesn't matter what direction they're traveling. It's just a matter of how fast it's going. I apologize for the sound effect. Velocity is a vector. That means it has size or magnitude. By the way, physicists hardly ever use a one-syllable word for something if there is a three-syllable word available to replace it. So instead of saying size when they talk about vectors, they always say magnitude. Anyway, velocity is a vector, meaning it's not just how fast, but how fast in what direction. So my velocity when I'm coming to school in the morning is toward the west, and when I'm going home, it's toward the east. So direction's important. Okay, I want to give you these two definitions of average speed and average velocity. Average speed is how far you traveled divided by how long it took. So it's important that you remember this, because average speed is not calculated by just averaging up the speeds. Sometimes that works, but it doesn't always work. So you want to be careful about that. I'm going to do an example in this presentation. Average velocity is the change in position divided by the time, and it depends on direction. So if you go around in a circle and come back to the same place that you started from, your average velocity for that time period is 0, because your position has not changed. Okay. So let's look at an example of the difference between velocity and speed. Let's say your physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. The entire motion lasts 24 seconds. So we're going to calculate my average speed and my average velocity. Well, I didn't mean to do that. I walked a distance of 12 meters, right? My total distance was 2 plus 4 plus 2 plus 4. That's 12. And it took me 24 seconds. So my average speed was 0.5 meters per second. However, I went right back to the place that I started from, so my displacement is 0 and my average velocity is 0. I know it seems tricky, but it's really just a matter of how we've defined them. Sometimes the magnitude of the velocity, average velocity, is the same thing as the average speed. Instantaneous speed, speed at any given instant in time, is found by the speedometer reading, and it's also found by the slope of a point on the position time graph, and we will talk more about that in sequential slides here. So average speed being the total distance divided by the total time. So your average speed does not necessarily match your instantaneous speed at a given instant in time. Instantaneous speed is how fast you're traveling at t equals 11 o'clock. And average speed is what speed would you have had to travel at a constant rate in order to cover the same distance in the same time. Okay, so a more formal definition of instantaneous velocity is that it's the limit of the average velocity as the time interval approaches zero. So we put a little arrowhead, it's like a little half arrow above the letter to indicate it's a vector. So this is velocity, and it's the limit as we shrink this interval that we're calculating the change in position for down to a smaller and smaller time. And in calculus, they call it dx over dt. But if you're not taking calculus, don't worry about that. Once again, it's called the instantaneous rate of change of position with time. Another way to think of it is that it is the average, it's the slope of the graph at a point. And so if we are interested in what the speed is at t equals 1 second here, we can find the average speed for shorter and shorter intervals until we just look at the slope of the tangent. Okay, acceleration, meters per second per second. It's the change in velocity divided by the time. And the units are distance over time over time. We'll talk more about that momentarily as well. Okay, here's the definition of average acceleration. It's the change in velocity divided by the time. And that means if you, let me go back there, if you have a graph of velocity as a function of time, you can find the slope of whatever region you're interested in, and that gives you the average acceleration, the rise over the run. If you have a curved velocity time graph and you're looking for the instantaneous acceleration, it would be the slope of the velocity time graph at that point, or the slope of the tangent. Okay, so acceleration units are in general speed divided by time. So meters per second, you will see. That's the same thing as a meter per second squared, and I encourage you to do some algebra to convince yourself that that is true. Sometimes you'll see acceleration measured in miles per hour per second, or that can also be written miles per hour second, kilometers per hour second, kilometers per hour second this way. It's distance over time, or distance over time squared is another way to think of it. So that's how this meters per second squared got in there. All right, so here's a checkpoint, and this is a graph of how you guys responded. If the velocity of some object is not zero, can its acceleration ever be zero? And this is what a couple of your classmates said. Velocity is speed and acceleration is the change of speed. If the acceleration is zero and the velocity is 1 meter per second, then the velocity would continue being 1 meter per second and not have a change in speed. If I remember correctly, velocity is the speed of an object in a certain direction. So, for example, if a car is driving north at 55 miles per hour, that velocity is not 0, but the car doesn't necessarily have to accelerate, making it possible to be 0. So, looked like 64% of you agreed that yes, it is possible. And I agree with both of these statements. It is possible. If you are traveling at a constant speed in a straight line, remember velocity has magnitude and direction. So if you change direction, you are actually changing velocity, and so you are accelerating. But if you're traveling in a straight line at a constant speed, your acceleration is, by definition, 0, because acceleration is the change in velocity divided by the time. If velocity isn't changing, then there's no acceleration. Okay, so I said this a couple times. I will say it over and over. Acceleration is the slope of the velocity versus time graph. It's the change in velocity divided by the time. And here I have a little, this is called a motion map, this little picture up here, showing where the car is every second. And you'll see it's equally spaced. And the velocity is constant here. Excuse me, there's someone at the door.